So this is 2019 question 5. So it says here, the crescent shown in the shaded part of the diagram was created by removing a disc of radius 2.5 centimeters from a disc of radius 3 centimeters. So I just drew in quickly. So this here to here to here is 2.5. The full disc then is 0.5. So this is full disc, which is 3 centimeters. So the first part of this question asks me to find the area and the perimeter of the crescent and give each answer correct to 2 decimal places. So I'm dealing with a circle and I have the area. So basically I have 2 kind of circles that I need to be dealing with because the crescent is part of this circle here. So the area of a circle is, I have pi r squared, so my area is equal to pi bracket 3 to be squared, and that's 9 pi. Okay, so that's my full circle. And then I'm going to get the area of my smaller circle, so my area is equal to pi r squared, so my area is equal to pi bracket 2.5 to be squared, and I get 6.25 pi. So then to get the area of just my crescent, I need to take the one from another, so I'll go 9 pi, take away 6.25 pi, and I get 8.64 centimeters squared. So that's part the area done, part I. Now I'm on to perimeter. So perimeter, I'm dealing with a circle, so that's my circumference. So my formula is 2 pi r, and like above the area, I need to get the perimeter of 2 of them. So I'm going to have c is equal to 2 pi r, and I'll get then c is equal to 2 pi radius 3, and I'll get 6 pi, and then c is equal to 2 pi r, and I'll get c is equal to 2 pi bracket 2.5, and I'll get c is equal to 5 pi. And I add those 2 answers together, 6 pi and 5 pi, to get 11 pi, which is 34.56 centimeters. So the reason why I added those together instead of taking them away as what I did earlier, so circumference or the perimeter, I got this part here, and then I got this part here using my 3, so that's why I added them together. So the circumference is outside of the circle, my perimeter. Part B then says an empty inverted cone of vertical height 12 and radius 7 centimeters is filled with water from a pipe. The water flows from the pipe at a steady rate of 0.5 litres per minute. Find the time it takes to fill the cone. Give your answer to nearest second. Okay, so we're given per minute second, so we need to anyway is I write down the volume of my cone. So I have my volume is equal to 1 over 3 pi r squared h. Fill into my formula, so I have volume is equal to 1 over 3 pi, my radius was 7 to be squared, my height is 12, and I get my volume to be equal to 588 over 3 pi. Right, and then my volume then I break down is 615.752161 centimeters cubed. Right, from earlier in the chapter we would have looked at 1 litre is equal to 1000 centimeters cubed. So to put this into litres, I'm going to have to divide across by 1000. So I'll get 615.5752161 divided across by 1000, and I upped by 0.5 because it tells me the water flows from a pipe at a steady rate of 0.5 per minute. And find the time it takes nearest minute, basically, or second. So I have this here to nearest minute, so I have here, this is my volume, I divide it by 1000, and I'm multiplying that also by 0.5 because that's the rate of flow, and I get 1.23150432 minutes. I was actually asked to get this into seconds, so I need to go from minutes to seconds, so I multiply it by 60, and I get 73.89025 seconds, and to the nearest second then I'm going to get 74 seconds. The next question you had was question 8. So it says here a solid sphere of radius 3 centimeters is placed inside a cylinder, and then water is poured into the cylinder until it's full as shown in the diagram. So find pi, so formula pi r cubed. So I fill in 4 over 3 pi, my radius is 3 to be cubed, and I get my volume is equal to 36 pi centimeters cubed. Part 2 of this then says a sphere is now removed. The internal radius of the cylinder is 5 centimeters. Find the drop in cm, the height of the water. Okay, so we know the height of the water is going to be affected by the sphere, so basically the volume of my sphere is equal to the height, the drop in the water. So my volume of my cylinder is pi r squared h, so I fill in what I know. So pi, my r is 5 to be squared, H I don't know, I'm trying to find the drop in the water, and I let that equal to the volume of the sphere because that's what we're taking out of the cylinder. So I then have 25 pi H is equal to 36 pi. I divide across by pi, and I'm left with 25 H is equal to 36. I want to get H in its own, so I divide across by 25 and I get H is equal to 1.44 centimetres. Then I have part 3, so part 3 says the cylinder has a height of 18 centimetres. The curved surface area of the cylinder is cut from the rectangular piece of metal measuring 35 by 20 centimetres as shown. Find how much metal will be left over when the curved surface of the cylinder is cut out. Give your answer correct to one decimal place. Right, so my curved surface area, the formula in my log tables is 2 pi r h. So I have 2 pi, my radius, which we had above, is 5, my height 18, so my curved surface area of the cylinder 100, my area 35. I'll take away my curved surface area to find out what will be left. And part B, so in September 2018 a European Commission report had stated that it is considering a proposal of abolished daylight saving time. This would mean that the clocks would not go forward 1 hour in March and then not go back 1 hour the following October. A transition year class carried out a survey to find out the local people's view on the proposal. Right, so it says here, the class surveyed a random sample of 800 people in the local area. Find the margin of error of the survey. Give your answer as a percentage correct to 2 decimal places. So now we're looking at introducing a bit of statistics or a bit of revision for you. So margin of error, my formula for that is equal to 1 over the square root of n, where n is my sample size. So in this case I have 1 over the square root of 800, which will give me 3.54%. Part 2 then says, in the survey 350 people said they supported the EU proposal to abolish daylight saving time. Use your answer to part B, I, above to create a 95% confidence interval for the percentage of population who supported the EU. Right, so my population, my p hat, okay, so this is my sample proportion. I have how many agreed over my total. So in this case 350 over my 800 is equal to 43.75%. And then to get my 95% confidence interval is going to be my p hat, my sample proportion, minus my margin of error, my p hat plus my margin of error, and that will tell me how many people fall within that 95%. So here I have 43.75 minus my margin of error, which was 3.54, my 43.75% plus my margin of error 3.54. So the population will be greater than 40.21%, but it will be less than 47.29%. And then here part 3, it says a local newspaper has reported that 50% of people in the area support the EU proposal. Use your answer to B, part I, above to conduct a hypothesis test at the 5% level of significance to test the newspaper's claim. Clearly state your conclusion in the context of the question and give a reason for your conclusion. Okay, so first of all, my null hypotenuse, so H0, is equal to 50% support the EU proposal. Then I have my H1, my alternative hypotenuse, is that 50% of people do not support the EU. So then looking at above there, I had the population that supported is between 40.21% and 47.29%. So 50% does not fall within that category. So I can't accept the null hypotenuse that 50% supported because my support is between 40 and 47%. So I reject the null hypotenuse as only between those two figures, and I have to accept the alternative hypotenuse is that 50% do not support the EU.